Okay, good morning, Mr. President and ladies and gentlemen. Now shall we go to next section? Okay, thank you. And next speech is Dr. Yanguang Liu from First Institute of Oceanography, State Oceanic Administration. Please. Okay.
Thanks, Mr. Chairman. Good morning, ladies and gentlemen. It's my great pleasure and honor to be here to make a brief introduction about the proceeding of marine geological survey based on the CHINARE5. My name is Yanguang Liu. I come from the First Institute of Oceanography, SAWA. I'm chairing the marine geological survey during the CHINARE5. Concerning the geological survey, our main target is to find the history about the depositional system and the global climate and its response to the global climate change. So first I want to show you the impact and importance of the abrupt changing of the Arctic. So from this figure we can see the Arctic climate has amplitude feedback from the global warming. As you know, about 70 million years ago, the globe climate is standing on a greenhouse climate system. Since 30, maybe 35 million years ago, the globe climate system changing to the ice horse climate system. Since maybe about 2.5 million years ago, the permanent iceberg existed in the two polar areas. So that means that during the Quaternary, our globe was shifted to the glacial and interglacial climate cycle. From the scientific results of the Greenland Ice Core program, we can see from the around 100,000 years ago, the North Hemisphere has undergone very quickly abrupt climate changes and many frequency and high amplitude climate change events have been founded from the ice core record, such as the DO cycles and the young ice core event. From this figure, we can see the global ocean, especially the deep ocean current system. You can see the North Atlantic is the beginning of this the ocean conveyor belt, So the tropic ocean is maybe the engine of this energy and the salt ocean current. So in modern climate pattern of the Arctic area. It can be divided into generally into two phases. One is the positive phase and one is the negative phase. That over the most of the past century, the Arctic oscillation alternated between its positive and negative phase. After the 1970s, however, the AO has tended to stay in the positive phase, causing lower normal Arctic air pressure and higher normal temperature in much of the northern Eurasia. Generally, that is the cold Arctic warm continent. So concerning the China's climate, it has been influenced by the Arctic climate system. From this figure, we can see the stream, the surface storm, is connecting the Chinese mainland with the high latitude of North Hemisphere. So that's why the climate record recovered from the Greenland ice cape can be related by the sedimentological record from the Chinese Loess Plateau and some lakes sediment records. Also, some Chinese scientists have done very good work in stalagmite. You can see the oxygen isotope record of the stalagmite has a good relationship with the solar radiation system of the northern hemisphere. So the changing of the isotope, it means it can instead of the rainfall, the participation in the central China. So it's worthy and necessary to carry out polar studies for China's sustainable development. So I want to show you the history of Chinese Arctic expedition. So from the end of next century to 2010, we have finished 4 Arctic expeditions. So the main investigation area in the previous expedition is in Arctic Pacific sector. So from this figure, I will show you some the working stations and the investigation area. In this CHINARE cruise, we are going to do the geological survey in Bering Sea, Swiss Sea, and the Norwegian Sea, Greenland Sea, and also the Icelandic territorial waters. The main target of marine geological survey is to investigate the sediments characteristics and their spatial and temporal distribution pattern. And the second target is to reconstruction of late Quaternary Paleoceanography, ice dynamics, and climate changes in Arctic. Also, we are going to do studies on the response of China's climate to Arctic rapid climate changes. As you know, for the marine geologic studies, in the field work, the main work is to get the samples. So first, I want to show you some cases about the sediment input. You know, in Arctic area, there are several sediment sources, such as the river discharges. There are some materials from ocean currents and the biogenic fractions from surface productivity. And also very important fractions is ice-rafted debris, also aliens, the volcanic eruptions, and so on. So from the samples, we are going to find the environmental proxies to reconstruct the climate changes history. I listed here several proxies. One is the microfossils, such as the foraminifera component of abundance is the very good proxy for the ocean current. And also the classic debris is very important for the georesources. Also from the lithological changes, we can figure out the depositional environment changes. In this course, these three methods are used to get the samples. The first one is box grab, to take the surface sediments for short-term record studies, and the multicore is also get the surface sediments to study the short-term records and also the pore water studies. The Geological is we used in this course is about 8 meters longer. It's for long-term record retrieving and the sedimentologic and oceanographic studies. Just several days ago, we on the way when the ship on the way to the Reykjavik, we have finished 2 courses in Icelandic territorial waters. So one is about with the core length about around 6 meters. I'm not sure about the sediment rate. Maybe Dr. Jung knows. So I'm not sure about how long it can reach. How many years can this course can reach? So from this, I want to show you some preliminary results of Chinese scientists got it based on the CHINARE5. The first is the sediment distribution studies. Based on the surface sediment studies, such as the foraminifera abundance, the silicon content, we can know, such as the Atlantic water influence in the Chukchi continent, and also some work to recover the rapid changes of the sea surface temperature by using the ioning biomarker. So from this figure, we can see the rapid changes of the record in the Central Bering Sea since the last 10,000 years, and it has a good relationship with the Greenland sea ice climate records. And this work, I want to show you some sedimentologic and paleontological studies about in the Triple Sea continents. So from this is quite complicated. I just make a brief introduction. So we use the foraminifer abundance and also the ice rapid debris, also the isotope, oxygen and carbon isotope compositions, also some elemental resource to recover, to reconstruct the productivity, ice melting, and the seawater features, and also the seawater temperatures changes since maybe since the last 40,000 years ago. Finally, I want to make some propositional studies for the future cooperation between China and Iceland. First is to study the distribution, origin, and the dispersion of the sediment, especially for the volcanic origin materials. The second is the sedimentary record of the abrupt climate changes and its linkage with the global climate. Third one is comparing studies on high-resolution sedimentological and paleoclimatic record between the North Atlantic and China. The last one is the ocean environment comparison between Arctic Pacific sector and the Antarctic sector. Okay, that's all my presentation. Thank you for your attention.
Okay, thank you, Dr. Liu.